Okay, now, believe it or not, we're gonna do part C analysis, and I'm not even ready to go. Here we go. Right. So here's the part B analysis, and so now we'll let's see, copy this and create a copy, and put it there, I guess. Okay, give Dropbox permission. Okay, I don't quite want that. Change, right. So, anyways, let's see. And, yep. And, so delete this, and alright, so previously you filled in this stuff here, and so we got the single coil data here. This is where I used a magnetic sensor, and so now we've got our Z data, and then we have to convert to X so we can feed it into that G of X. We got our V peak to peak out of our oscilloscope. I don't see any equations here, and so just copy them from here so they're in front of us, and just paste them as original format. So let's think about this. So B sub 0 is, okay, see, I just got home, and search coil 2 pi. Oh, here's the search coil. Okay. So B experimental comes from the search coil, and yep. Okay. So the 2 pi times n of s times the area, which using r of s and r and s, so this is the same as the single coil because you're using the same guy to measure it. And so then it's that, but we have to divide by 2 because we got voltage peak to peak. Okay, so voltage peak to peak divided by 2 pi NSAF, which we just made a single quantity up there. It's got well, let's do a zoom in. Well, they won't be able to see that, but let's see, because things are too far apart. Let's see where we're at. 100%. Let's try 125. There we go. All right, so EMF divided by, which is then the V peak to peak divided by 2, and then divided also by this number here. So then we fill it, and we didn't actually do, I forgot to have you guys do a plus minus, so we are doing 0.5 times what? 0.5. All right, 5%. In this case, did 3% for the other one. I made them 5% here. Okay. So now we're ready to plot our data. And hold down the control key. And HH, of course, stands for Helmholtz. And insert menu. And, now what would happen if I, oh, now that's herky jerk, well, because that's data. I'm going to try this because remember the line, well, we may, assuming you have watched the other video, you might remember that the line, the fit line was jerky. So, no line. Nice. Okay. So then, highlight the graph. And for right now, you notice that this is, while we're here, we can clean that up. And I'm going to just put 2 decimal places. And that's prettier looking. Certainly needs labels and such. So we want to add error bars. We do this now before we bother with the fit line, because now we just have to get rid of fix one set. If we did it before, it would put error bars on both the fit line and the data set. And it's just making work for ourselves. So X is 0. And then we got to get ready here. Oops. And of course, Mac users format and X error. No, we already did that. Y error bars. Okay, so we want custom, specify, and we pick our plus minuses there. Oh, I goofed. Here we go, negative error bars. Excuse me. And bingo, we have error bars. All right. Okay, now we need a fit line. And the fit line comes from this guy, although in our case, that's not completely true because we need the Helmholtz. So let's see if that's available somewhere. And apparently it's not. That's weird. Whoa, let's see if it's here. Huh. Very weird, but we have some redemption because we know that all we have to do is substitute g of x for f of x, and and then this is coming from here. And so g of x, so we can just steal it because we've done it previously. And let's see, it picks up the x value. So then let's just copy and paste. Now that's not going to be the right number because it has to pick up the x value. And the x value is in column x. So we have to change this to column x. See, now that's it. And chop chop x. Alright, now, yeah, 1.43108, that's what we expect. And now we have our g of x. So then we have our b theoretical. Oops. Oh, I guess I could have. What's going on with the font? And that equals to this convenient thing we made with dollar signs F4. Oops. And times g of x. There it is. And there's our, that was going to get us our, okay, or fit line as you will. What is it? Times New Roman Calibri. I wonder what's going on here, but Calibri and 11. There we go. Now, let's put that on there. And we need to select data. If I can find it. There it is. And I'm getting old, I guess. Add. B theoretical. And then the x values. Hopefully I can get them. And I'm going to go one extra. And then the y values are here. And one extra. And we'll say okay. And okay. And something went wrong. And of course I want to oh, and I have to drag this down too. Okay, that's what happened. I scaled wrong. And that's just because I want the fit line to go past the data points. That's all. So I select the chart once again. And format, and then data series, B theoretical. And I think, yeah, the paint can. And I want a solid line. We want it to be red. I always like it to be red. You can make it any color you want. Make it small. And then marker. Marker options. None. And there we go. Okay, so now let's get our fit parameter table. And now in this case, it's not y-intercept and slope anymore. Scale factor. And the next one was offset. And only vertical. Now, you may recall it didn't work out too well with the single coil data. And we'll just start with number here. So then we have the sum of the res squared, the sum of the chi-square, which, since we're not getting an error, is not quite as necessary as before, but it's just a good habit. And then the sum of SS total, which you know what that is from looking at the other analysis video. Okay, so in anticipation of that, I've taken the what's going on? Ah, there we go. I took the average of the data, and so of course, you know what, where the R squared variable goodness of fit. So we have our res squared. We have our chi squared, and we have our SS total. Ooh, and just to make things look nice, neat, and clean, we'll insert a column there. So this is equal to the data minus the fit, and oops, what happened? Oh, and squared. Now, one thing we haven't done, so let's assume these are going to be needed to be scientific in 2 places for the time being. And then this equals the res squared divided by the plus minus squared, which is kind of anticlimactic because they're all the same. And then this one is the data. Oh, I forgot equal sign. Equals, open parentheses, data minus the average, and we need our dollar signs, and close it and square it. Okay, sure, we can go ahead and fill those. There we go. And what we need to add to this is the scale factor and the offset. Oh, we can do it here. It's easier to see. So parentheses around the original quantity, and then times the scale factor, which we need dollar signs again, and then oops, what happened here? F4, and then I'm just going to click in here, and then plus the offset and the dollar signs. Enter. So this won't change much at first. Oh, we need it to be all the points. And so let's give it a try, 0.95. And there it goes. Okay. Ah. Yes, I'm drinking a beer. My favorite Guinness stout. Okay, so we can add some orders and add some board. Well, let's do this. Merge and center. The fit parameters table. Get a little fancy. So this equals the sum of the res squared. And obviously that's not 0. We have to do something there. Equals the sum of the chi-square. And did I remember to close the parentheses? It should give me an error if I didn't. And equals the sum of the sum of the square total. Yeah, I think it's sum of the square. I can never remember that one. So this, probably both of these are going to be scientific. And this one looks like it's going to be scientific. And of course we can do r squared, and that equals 1 minus the sum of the res squared divided by the sum of the totals, sum of the square total. And of course we need 4 decimal places. So already it's pretty damn good. Let's put some borders on it. And so now we'll try the solver. Quite understand what that's about. So we want some of the chi-square. Toby. Hey, stupid dog. No. Toby. He's making the world safe for democracy. And scale and offset. And let's try it. And, oh, it converged. Well, look at that. And look at that value. Sweet, huh? He's trying to go out the back door, but I got it closed, the doggy door closed, because my wife doesn't have to deal with him. But he will explore. Okay, so look at that. That is stunning, huh? And of course that needs to be cleaned up, and you need to, put all this up in your cut, paste, print it, cut it, Mr. Ordonez, sorry, and paste them in, and then explain what's going on, blah, 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 blah. Okay, I'll get this up to YouTube.